I'm sure as a Python developer, you would have heard or maybe even used decorators in your project. They are one of those powerful tools that once you get comfortable with can really change how you write your code. And today I'm going to walk you through 5 real world use cases of decorators that can be super helpful in your project. Two of which is my most favorite, the watcher and the cache manager. But before we dive into that, let's make sure we understand what decorators are, how they work, and to do that, we will start with a simple example. Let's say we have a function that just prints a message. So let's create a function here, def greet, that will simply print a message. Hello, welcome to my YouTube channel where we discuss about Python concepts in detail. Cool, let's call this function and see the output. Hello, welcome to my YouTube channel where we discuss about Python concepts in detail. Nothing fancy, right? But what if tomorrow I want to add little extra message to this function? Maybe we want to add some more lines. So one way to do is to modify the function itself. But what if I don't want to modify the original code, or I'm not allowed to do so? This is where decorators comes in. Now, a decorator is basically a function that wraps another function to add some extra behavior. So let's define a decorator. Def extra text. This will take our original function as input. We'll create an inner function, and then we will call this our original function here, and then print, and we also talk about real-time use cases of Python concepts. Please like and subscribe. And then we will return this inner function. If you are not getting anything here, no worries, I will explain line by line. So let's redefine our greet function, but this time we'll use our decorator. Extra text, done, and we'll call the function again. Perfect. So now we have hello, welcome to my YouTube channel where we discuss about Python concept in detail, and we also talk about real-time use cases of Python concepts. Please like and subscribe. So what's happening here? This extra text function, when applied to our greet function, it actually wraps up the greet function inside the inner function. And when we call the greet function, the decorator gets executed, taking our greet function as an argument. It then returns the wrapper, which is inner function here in our case. Now the inner function has access to the original greet function because of a concept in Python called closure. A closure allows the inner function to remember the context of the original function even after the main function has completed its execution. I will make a detailed video on the closure soon, so please don't forget to subscribe to my channel and stay tuned for that topic. Now coming back. So once the original function greet is decorated with the decorator, it's effectively replaced by the wrapper, which is nothing but an inner function here. Now this wrapper function calls our original function as part of its behavior, which allow it to retain the original functionality while adding some extra behavior as well. And here's what we get as an output. So this is how we added that functionality without changing the original function itself. And that's the magic of decorators. This was some very basic example of decorators. just to explain how decorator works. Let's move on to real world use cases now. So first we will build a watcher. The watcher will monitor our function and do two key things. It tracks the execution time of the function, how long it takes for the function to run, and it will also log arguments. It will show us the values passed to the function, including both positional and keyword arguments. This can be really useful if you are trying to optimize the performance of your function and debug issue, or simply understand the behavior of your function. I have prepared two functions already. The first function is add, which simply adds two integers, and the second function is again the greet function. Let's create our watcher. This will take our original function as input. We'll create a wrapper here. Which will take args, quarks as argument. Let's create a variable, start time, time.time, call the function, end time, time.time, calculate the execution time, end time minus start time, and let's log few information here. What we want to log first? Which function was called? So function func dot name is called with, then we want to log arguments, args, and we have two type of arguments here, positional and keyword arguments. So we'll print this as well, quarks and last we will print the execution time. This function took to complete execution, and then we will return the wrapper. Okay, so let me walk you through this code once. Here our watcher decorator function takes another function which is nothing but our original function as an input, and as you can see inside the watcher we have defined a wrapper function, and this wrapper function will be responsible for printing the function name and other information like args, swags and the execution time. Here we are calling the function, the original function, and tracking the start time, end time of the execution and calculating the execution time, and using the same information here to print the execution time of the function. Alright, let's use it. So first we will redefine our add function, but this time with our brand new watcher. And we will call this function with two arguments 4, 5, and it is executing. Perfect. So function add is called with argument 4, 5, quarks nothing. This function took 5 seconds to complete the execution. Let's use our another function, greet. We'll use our watcher here as well and call greet. So it prints hello John. Function greet is called with args nothing, coax nothing. One point is to notice here, this greet function has default arguments passed. If you are not passing anything, it will definitely take default value. So this function took 0 seconds to complete the execution. Now what if we pass a value while calling the greet function? So it prints hello Dheeraj. Function greet is called with args nothing, coax name Dheeraj. This function took 0 seconds to complete the execution. So as you can see how our watcher function is acting as a monitor of our add and greet function. This watcher decorator logs the argument, tracks how long the function takes to run, and displays the result. And this type of decorators can really be helpful in understanding the behavior of your function. Alright, let's move to another use case. Okay, in this example, we will make an access manager decorator. This one is useful if you have a function that should only be accessible to a certain user, like which has some admin permission. For an instance, you might want to allow only admin users to delete some data, while regular users get denied access. How to do that? I have already created a function, delete data, which simply prints a message like data deleted. And we have created a user object, which is having an attribute called as admin with a boolean value false and true. Usually in real-time scenario, when you are using Flask or Django applications, you will get user object in the request context itself. But here we are not using any application, so I have just created a user object to use it further. Alright, let's start the code. Let's define our decorator called require permission, which will take again the original function as input, then def wrapper and our args and keyword argument cogs. And before calling the original function delete data, we will check if user has admin access or not. So here we will do if user dot get is admin, then only call the function, else print permission denied, only admins can perform this action. And then return wrapper. So let's go through the code once. Require permission is our decorator, which takes our original function delete data as an input. Again, we have an inner function, the wrapper, which will have the access of our original function. And here, before calling our original function, we are checking if user is admin or not. If not, then it will print the permission denied error, else it will call the function. Alright, let's use this. If delete data, will redefine the function, but this time with our require permission decorator. And now we will call this function. So as we can see here, it's telling permission denied, only admin can perform this action. Now what if I change it to true? So now the user is admin, we are able to delete the data. So as you can see, our access manager decorators ensures that only user with admin privilege can call the delete data function. And this is a great way to enforce role-based access control in your project. Alright, let's move on quickly to another use case. As our next example, we will use decorator to retry our failed operation. Let's say you are making a network request and sometimes it fails due to network issues. And you can use a decorator to automatically retry the operation a few times before giving up. I have already prepared a function called unstable API, which randomly raise exception if the value evaluates to true, else it will print operation successful. So if we call this function here, it gives us API error, try again. Again it gave error. And if you call multiple times, so now it is successful. Here we try to execute the function multiple times manually. And now we will try to automate it using decorator. So let's create our decorator now. Def retry, that will take original function as input. We'll create a wrapper and then args, cogs, and we have to execute this function some given number of time. We'll do for I in range given number of times return function try. We'll use try except block because it might fail also. Except exception as e print retrying error e. And even if it doesn't execute successfully after multiple attempt, we'll do print failed after multiple retries. And then we will return our wrapper. So as you can see here, this retry decorator will be accepting function as an argument, and this wrapper will be taking the arguments and keyword arguments passed to this function. But we are using one more variable here called times, like for how many attempts it should try. How we will pass this value to our decorator? For this, we will use the concept of decorator factory, where we will pass how many attempts our decorator should make. We will make the default value as 3, and then all this decorator will go inside this, and then we will return our decorator here. Syntax error, expected diff max try. Okay, perfect. So now we have our decorator ready. So this is our decorator, this retry, which we are returning here, and the max retry is basically a decorator factory that will actually returns a decorator. So this concept is used when you need to pass extra arguments to a decorator apart from the arguments you are passing to the original function. So, and instead of directly applying the decorator to the function, we will call the decorator factory. That will actually produce the actual decorator. Now let's use it. So we'll copy this unstable API function, and this time we'll use our decorator factory max try, and we will call this function unstable API, and you can see here it is telling retrying error, API error, try again. So first time when our function got executed, it actually raised an exception. Then our decorator retried it, and that's the second time it executed successfully. And now it executed successfully in the first time itself. And here you can see, so first attempt, trying again, trying again, trying again, and then you can see here failed after multiple retries. So even if it tried for 3 times, but every time it raised an exception, so there should be an exit. So it tried for 3 times and then failed after multiple retries. What if we want to try for a couple of more times here? Then we can pass the value times equal to 5. Oh, sorry, I I have to pass this times value here. So as you can see here, now it tried for 1, 2, 3, 4 times, and then on the 5th times it was successful. So that's how you can manipulate the number of times it should try to execute the function. So as we can see, this decorator will automatically retry the operation up to 5 times before giving up. So this type of decorators are super handy for handling unreliable network requests. Alright, let's move on to next use case. So our next use case of decorator is to use decorator as a validator. So let's say we have a function called add. Remember the same function we used in our first use case of watcher. So if we call this add function 2 or 3, what it returns? 5. But what if I pass a and let's say 1 and 2? What it returns? It's a type error. It can only connect string or integer. We have created a function. We don't know how the user is going to use it, right? It might pass a string, it might pass an integer. If you are taking input from terminal or some form input, how the data will come to us, that we don't know. So to handle this kind of scenario, you can use a decorator to automatically check that the input to a functions are valid before the function executes. This is especially useful when dealing with APIs or user inputs. So we will create our validator here. Def again wrapper for I in args, for I in args, if not is instance I integer is value error input must be integers, else return function and then return wrapper. So let me walk you through the code once. So this is our validator decorator, which is taking function as an input, and we have defined a wrapper function inside our decorator. And these args are nothing but the arguments we are going to pass in our original function adds. Then we will check in args if any of the given argument is not integer, then it will raise a value error and it will not call the function. Let's use this and def add and our validator. Now we will call the function here, one string and one integer, and you can see here input must be integer. So that's how we are validating the input before passing it to our function, and if it doesn't meet our criteria, we are not executing our function itself. One more thing we can do here is, instead of throwing an error, since we know our add function is expecting integers, we can validate the values passed by the user. If it is in a string, we will convert into integer if possible. So for that, what we will do here is, we'll create a empty list num, and then we'll do num if int of I, if not is instance, else I, and then nums dot append num, and instead of args we will pass nums now. Perfect. So now our decorator function is checking if 1 is coming as string, it will convert it into an integer and then execute our function with the expected input. Nice. Let's move on to our next example. Last and one of the most useful use cases of decorator is cache manager. If you have a function that performs an expensive operation and you want to avoid recalculating it every time with the same arguments, you can use a decorator to cache the result. I have already prepared a function compute square which is used to compute a square of a number, and it could be any expensive operation as well. To use this function, we will use compute square 3, it gives us 9. Again, if we do with the same argument, this function is again executing to compute this square. What if we can do something like it caches the result of a square of 3 and return from the cache instead of running the function again? So let's create our cache manager. So we'll create a function cache which will take our original function as input. Then we will create a wrapper with args and cogs pass return wrapper. Now, in order to make our decorator return cached result, we need a place to store the output from the function when it was called for the first time. So we will create here a variable called cached result, which will be a dictionary, and it will store the result in key value pair where args will be key and the result will be value. Now, before calling the function, we will check if this args is already available in the cached result. We will return the already calculated output, and if not, we will call the function. So let's do that. If not args in cached result, then cached result of args and then return cached results args. So let's go through the code once. So this is our decorator which is taking original function as input. We have created a variable called cached result to store the output of the function when it was executed for the first time. Then we have an inner function wrapper which is checking if the passed argument is already in the cached result, then return the cached result, else call the function, get the output and store it in the cached result. Now let's use it. So we'll redefine the function, and this time with our decorator. I will call compute square 3. So it is saying computing square for 3, 9. If we call again, it just gave 9. For better picture, we can add one message here, storing data in cache. So now if we call this 4, it is computing square for 4, it called the function, then storing data in cache, the output is 16. Next time when we call this with the same argument, it just gave us 16. It didn't actually call the function. It returned the value from cached result. And again, if we call this with another argument, it is again computing and then storing the data in the cache and giving the value. As you saw in our multiple use cases, the concept of closure was heavily used. Understanding closures can help you unlock even more powerful pattern in your Python code. In my next video, I will make a detailed deep dive on closure, so stay tuned and happy coding. And if you found this video helpful, please don't forget to like, subscribe and hit the bell icon so you don't miss out on more Python content.